Pronto, vamos começar agora. Faltam
Onde é que está?
30 segundos. Vai, já está.
Welcome. Welcome to ACC's first webinar. Today we have as a speaker Rui Palavra and myself, João Fernandes, as the moderator. Once again, good morning, good afternoon, and good evening at this webinar on Learn how to reduce noise in power transformers. Before we get into the details, I would just suggest that you log in with your Gmail account to be able to present questions in the chat alongside the webinar. So, what is it we're going to talk about? Well, Rui will be recapping on vibration control basics, noise reduction strategies, and of course, accessing the power of the noise and vibration design tool through key calculations. Throughout the webinar, feel free to present your questions in the chat alongside. These will then be answered at the end of the webinar. So, Rui, be my guest.
Thank you, João, for the introduction, and thank you all for attending the first ACC webinar. This is the agenda for today. So we're gonna go through the VC basics, recap some of the VC basics. We're gonna talk about the 4 noise reduction strategies, and we will end up doing some case studies using our new NVD tool. So let's start recapping VC basics. This is a typical vibration transmissibility curve. The key message we want to show you is that a higher thickness of the pad provide a higher isolation for the system. Also, a higher pad thickness, when increasing the pad thickness, the natural frequency of the material will decrease. And this is important. Natural frequency is important because our material exhibit a natural frequency way below from the disturbing frequency of the transformers. As you can see in the graph, the natural frequency, even in a thinner thicknesses, it's below 40 Hertz, which is way below from the minimum 100 Hertz disturbing frequency of the transformers. The VC formulations combine the best of the 2 worlds. Basically, we are using the benefits of rubber, a very isolative material, and also using the benefits of cork, which has a high dampening factor. So VC materials have a high loss factor, resulting in a lower amplification at resonance. Shape factor. Shape factor is an important key factor to take in account when designing VC solutions. The very low Poisson coefficient of VC materials, due to the cork structure, allows for a wider shape factor tolerance.
Excuse me, Rui. What is the Poisson ratio?
The Poisson ratio, you can see it on the slide, is the ratio of the loaded area and the area, the sum area of the perimeter surfaces. So allowing for a wider shape factor tolerance result in more freedom to design and a more robust solution, and also allow us to customize solutions, not to be dependent on standard dimensions. Going for the four noise reduction strategies, we'll go see the four, and you can see it in the next slide. It's a sequential approach. And why? Because we need to start treating the noise the nearest from the source of noise. So in that sense, we should use these strategies starting with internal vibration pads. So using pads under the active part, then looking at the core clamping mechanism, which is basically to decouple, in a simplistic way, to decouple metal to metal connections from the active part to the tank, to the top or to the sidewall. Then you have the CLD, which stands for compressed layer damper, which is a solution for the tank wall. And finally, it's the external vibration pads to be used outside of transformers. Looking a little deeper to each solution, we're gonna start by the core clamping mechanism decoupling. And as the name says, the idea is to decouple the metal connections. So it's important to identify the connection points in the transformer using the VC2100 material, which is the only one that can be used inside the transformer. And it's important when designing these solutions, we don't have, or we don't offer any standard solution for our customers. We give some guidelines for the technical departments and mechanical departments to design the final solution, because every company has its own design, transformer design. So the guideline we give is that the material to decouple the metal connections should not be too compressed, too stiff, in order not to have a rigid connection. So the material should be compressed around 10% as a guideline in order to have a flexible connection. That's what we want, is to create a flexible connection. Going forward to the CLD, compressed layer damper, which is our newest solution, but already implemented as a standard one by three big players in the market. So we have actual data on this. and good results. And the mechanism is to dissipate energy. The sound that travels through the oil and hits the wall, bending it and making it acting as a speaker, transmitting the noise to the surrounding. Using this solution, which we can call it a sandwich solution, we are on the first stage stiffening the wall, so not allowing for the wall to bend as much as before. And by the incorporation of the material VC2100, again because it's inside the transformer, so immersed in oil, part of the energy that hits the wall will be dissipated by shear forces, and by doing that, the energy that goes to the surround, the sound that goes to the surround will be lower.
Rui, looking at the schematic on the slide, what thickness is usually used on the CLD?
Typically, and the thickness our customers are using and we are proposing and promoting to the market is 9.5 millimeters. We end up with this dimension after a few trials with different thicknesses, and we found out, along with our partners, with our customers, that the thickness of the VC material should be similar to the tank wall thickness. So now we standardize the 9.5 as the best solution, although other thickness can be used. Looking at the pad design guidelines, and this is valid for exterior or interior pads, the only thing that will change will be the material. But in order to define the right pad, we need to have the information, all that information you can see in this slide. So basically, we need to know the frequency, the disturbing frequency of the system, which for transformers, we know that will be 100 Hertz and above. For other equipments, could be much lower, but for transformers, we are looking always 100 Hertz and above. We need to know the temperature at which the material will be subject in order to find the right material for that temperature, the medium, and when we talk about the medium, we need to know if the pad material will be used inside the transformer or outside the transformer, if it's gonna be if it's outside, if it's going to be indoors or outdoors, and that information will allow us to select the best and the suitable material. The center of gravity, it's important to know how to distribute the pads under the transformer or under the active part in order for not unbalance the system. And finally, we need to know the mass, the weight of the equipment, the dimensions, and any constraint.
Rui, can you just explain better what you mean by constraints? What type of information should be requested?
One example, it's easier to talk with examples. If there is not space to in the transformer, in the design of the transformer, to introduce a pad with 40 millimeters, so constraint could be the available space to introduce a pad is maximum 20 millimeters thickness. So based on that constraint, we're gonna have the thickness not as a variable, but as a fixed information, and we need to design taking that in consideration. Other constraints could be the available footprint area where we can position the pads. Talking about the pads and materials, we have, and you all know our product range, T&D product range, or in this case VC product range. We have 4 materials. Going through very quickly on those, VC2100 is the only one that is validated and approved to be used inside the transformer, immersed in oil. Then we have VC7000, which has a high temperature resistance, typically used on dry transformers where the temperature is much higher than in oil-filled transformers. And then we have VC1047 and VC6400 that must be used outside of the transformer, being VC6400 a premium one because can be used with good results outdoors. Knowing the materials, we could go forward and focus on the key calculations on the vibration pad design. So our new NVD tool, and the idea today is to go through some case studies and show you how the tool works. Going through these case studies and doing some possible designing some possible solutions also hopefully will help you to understand better the tool in order to explain it also to the customers.
Rui, how hard or how simple is the tool in using by a simple, unprofessional or untrained person?
This software was made to be very intuitive and user-friendly, and I'm okay to say it because I didn't made it. So it's a tool not to an expert in mechanical engineer or chemical engineer. Almost anyone with the basic concepts can use this tool. So let's go entering the noise and vibration designing tool. The first option is select your application environment. So you don't need, or our customers don't need to know if the material to be used is the VC6400, if it's the VC2100, or else. They just need to know where they're going to use the material. So you have 4 options: internal contact immersed in oil, external contact in ambient environment, and external contact in enclosed ambient and high temperature environment. And by selecting one of these options, the user is selecting the right material for that application. So now it's time to make the webinar more live. And what we are going to do, we are going to simulate a few real cases, and we are going through the software. So I'm going to show you the information is not is part of the information that we received, but is the most important. So you can see part of a transformer where we have the the legs, the footprint, we have the legs, we know the mass, we know the weight of the active part in this case. We know that the VC pads are going to be used internal. So with providing this information, we are going to simulate in the software and see one possible solution. There isn't one solution, one correct solution. Can be several different solutions that we can provide to the customer, and we're gonna do some simulations and do some examples for you to see the ways we can do it. So first slide, you must remember we have 7 different legs with different dimensions and a weight of 48 tons, and we are going to use internal pads. So let's go back to the software. So it's internal contact immersed in oil. First is easy, and by doing this we are automatic selecting the VC2100 material. Going to step number 1, application input. So in gray you will input, in red it's the output. So the software will calculate based on the input and give and calculate the values. So mass in kilos. So important to say that the software is designed and using international system units. So the weight was 48 tons, so 48,000 kilos. Disturbing frequency. If the disturbing frequency is not given by the customer, we can assume that at least will be 100 Hertz. Transformers will not work below 100 Hertz. And this is typically service temperatures. If the customer gives us a different service temperature, we can adjust and select a different temperature. Here we have in Celsius and in Fahrenheit also. So assuming that the service temperature is within these limits, which typically it is, we can continue to step number 2. Too fast, too fast, too fast. Okay. So in step number 2, and knowing that there are 4 legs in the supporting the active part, we are going to define the size of the pad. We have 2 options using standard sizes. So if you go and select.
Excuse me, Rui, what do you mean by standard sizes? Is this something special?
Standard sizes is the sizes that are most used worldwide. So basically we tend to standardize some dimensions in order to help our customers to have not many different sizes for different transformers. And because of that, we define as a standard sizes also to help customers when they do not know which size they can use. Standard size will help them to guide through the software. But for more expert customers or for more special cases, we can use customized sizes. And on customized sizes, we can introduce any size we want. And then select thickness. Let's start for this example, and we go in a few moments to the customized sizes. Let's go and start with standard sizes. So we know that this case has 7 legs. So let's try by choosing 300 millimeters length by 200 millimeters width, and then we have available 3 thicknesses, 20, 30 and 40. We are going to use 40. As I said before, the higher the thickness, the higher the installation, so the higher the performance. So let's fix the 40. And by doing this, the software will do the calculations taking into account the weight of the transformer and the material that was selected in the first screen, and will help us defining how many pads we should use for that application. So depending on the limits of the material. So the software is saying you should use between 6 and 15 pads for this solution.
Excuse me, Rui. What do you mean between 6 and 15? What is the impact in choosing the lower limit or the upper limit?
We can simulate. Let's see, 6. The impact when we are using less pads, the contact area of material is lower, meaning the stress on the pad is higher. So you see with 6 pads, we have 1.3 megapascal pressure. If we change to 15, the pad stress decreased to 0.5 megapascal, which is basically, instead of knowing that material should work between 0.5 and 1.5 megapascal, with the stress limits of the material, the user doesn't need to know that information, because the software will direct for and define the limits not based on pressure, not based on deflection, but based on number of pads, which is much easier. And again, if we have 7 legs, we could use 7 pads or 14 pads. Let's try the 14 pads. As you can see, with 14 pads we have 0.6 megapascal pressure, and the shape factor is within the acceptable limits. If we continue to selection, we will have an overview of the transmissibility curve. Also, you can see the transmissibility value and the insulation value, also as the compression on the material, the deflection of the material. And if you click on the report, the software will generate a report with all information that we input and also the output from the software. You cannot see it, of course. You can then print it or save it as a PDF and send it also to your customers, or our customers could send to their customers if they need, or if they need to archive the information.
Can we save it somehow?
Yes, I'm gonna do a live example, so you can save it. I'm going to save it in the desktop application report. I'm gonna call it case 1, data, and done. So we have the information, but we can also, we don't like we want to change the solution. Okay, it's possible. We come back and we want to increase the stability of the solution. For instance, we want more number of pads. So what we can do is, as we are in the limit of number of pads, is to decrease the size of pads. For instance, 200 by 200 millimeters, using the same 40 millimeters, and you can see that the number of pads changed because we have changed the size of the pads. So again, we have 7 legs, so we want to distribute the number of pads through the legs, so the same number of pads per leg. So 7, 14, 21, and with 21 pads we didn't change much the pad stress, so it's almost the same, and the isolation percentage is almost the same, but basically what we are doing here is having more pads, and in some situations it could be helpful to use smaller pads in higher quantity depending on the system. In other cases, and you will see another one, we can use less pads with higher area, bigger pads. Also, an important thing with the software will guide us when inputting some information that is not accurate or it's not correct. And I will do an example using customized sizes. I could use 900 millimeters length by 500. By doing this, the thickness is not available. You don't have any thickness available, and the reason is because with this size, the shape factor between 10 and 40 millimeters will be out of range. So we can change the width, and then we can use the 40 millimeter thickness. Of course, I just input some random numbers. The number of pads between 1 and 2 when you have 7 legs doesn't make sense. But the idea here was to show you that the software will help and will help not to make errors. Finally, I want to show you, using the same example, the difference between using different thicknesses with the same size. So now I'm going to change customized 150 square, and we have 4 thicknesses available: 10, 20, 30 and 40 millimeters. Let's select the minimum and maximum case.
Rui, just one question.
Sure.
Are these thicknesses available for all the materials or in all situations, or is it very specific?
No. If the thicknesses are showing there, it's because they are available. It's because they are available. Other thicknesses can be supplied, but these are the standard dimensions that we have to provide.
So that means that if there is some type of engineering constraint, that we are able to do it in a different thickness.
Yes.
Okay.
Yes. And as long as the shape factor of the pad is within the limits. So let's try the 10 using the same example. So 7 legs, we are going to use 3 pads per leg, and we are going to consider the 10 millimeters. I just want to highlight the isolation percentage. So 85% isolation using the 10 millimeter thickness. So retain 85%, please. And now I'm just going to change to 40. The only thing that changed was the shape factor, of course. And we are going to use the same 21 pads. So you remember 85% isolation with 10 millimeters, and with 40 we increased the installation percentage to 94%. So again, increasing the thickness, we are increasing the installation of the materials. We have 2 more case studies to do, but we are in our limit, so we are going to send you the other case studies for you to do. Although you can see there the possible solution, but you should try to find the solution or to test with the software and use the software, and if having any doubts, please call me, email me, text me, whatever. The idea is for you need to make some homework, and you will have the PPT after this session. So any doubts, we are available for answering your questions and doubts.
Okay. So thank you very much for all of you being present.
Sorry, João. Just to end up with this case study, so we did several simulations. One possible solution was the first that we did, could be this one. So different sizes for the legs with one standard solution. Sorry, João, for interrupting.
No problem. Can you just go through the other 2 case studies?
Yeah,
Let's
sure.
see what type of homework we are giving.
So this one is 200-ton transformer external pads. You will see one possible solution, but it's important for you to go through the NVD and find this or other solution that makes sense. And we had another 102 tons internal pads that we had 2 possible solutions. One using just 1 pad dimension, another solution to increase stability using 2 pad dimension.
Okay. Well, we got to the part that everybody was waiting for, so I hope you've put your questions on the chat alongside the webinar. We can see that Diogo has been very active. We have 2 questions from Diogo. One of them, Rui, is if it is possible to have more than 1 pad dimension in the solution.
Using this software, it's possible, but not using this software. So this software, in order to be more user-friendly we design it in order to be possible only to have one pad dimension. So if for some reason, and the case 3 was that example, if for some reason we need to design a solution with 2 or 3, more than one pad size, this software cannot be used. There are other softwares that we can provide, and also we are open and of course to help you and help our customers to design different solutions. Next question.
Well, the next question we have is if the thickness of the pads are proportional to the equipment weight.
The answer is no, it's not. As you saw in the last simulation we did, changing the thickness will change the performance of the material. Will increasing the thickness will increase the performance, the isolation value of the material, but is not related with the weight. We can use higher thicknesses in high weight transformers or low weight transformers.
And we have another question here from a phantom assistant to our webinar, which is okay. So I have joined the webinar too late, like Victor was explaining, very irritated a moment ago. Can I see this again?
Yes, of course. The session was saved, so the session will be available as long as and also the PPT will be available, and this session was recorded in order to be available for all of you. And of course, we are still here if any doubts, you still have any doubts.
Okay, so I think that we all, at least the team, the GSM, marketing, and the whole industry, people involved, are very happy to have made this the first ACC webinar for the power industry. As Rui was saying, we will have a client-based webinar in October. You will be informed in due time so that you can also spread the good news. And ultimately, we hope you did enjoy and that it was useful for your training and also as a platform of good learning practices. And the next steps, like Rui was saying, we will distribute a PowerPoint with the homework, of course. If you have doubts, Rui is always available to enlighten you. And please don't forget, you can always download the noise and vibration design tool from our homepage and also propose it to your customers and contacts, as it is a standalone tool that works on any PC. So, once again, thank you very much for making this a success.
Thank you. I just want to add, your feedback will be important in order for us to improve for the next webinars.
Well, there is another couple of questions by Victor. I think he came on a little bit too late, so he is a little bit off on his questions, but we will for sure enlighten him as soon as we get back to the office. Thank you, Victor, for your participation. You came late, but you came strong.
Thank you again, and we all be happy. Bye-bye.
Bye-bye.